Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7 and today we are going to present about flow visualization of spinning and non-spinning soccer balls using computational fluid dynamics. Before we start, this is our team uh, that consists of HAZIQ, SYAKIRIN, ZULHAKIMI, AMIRUL and me, HADI. Definition: investigated the aerodynamic characteristics and large-scale dominant vortex structure of a soccer ball using a combination of the lattice-Boltzmann method, wind tunnel test, and free flight experiments.
Next, I will discuss about the history of the application of spinning and non-spinning soccer ball using computational fluid dynamics. The history is vortex structure in the wake of ball are almost unknown. One of the main computational fluid dynamic methods used for the analysis of vortex structure are the lattice-Boltzmann method, as it facilitates high precision analysis. Next, to explain the dominant vortex structure are important because curly shot and pass involving spinning ball are frequently used in actual soccer ball. And the lastly, of course, in this application is to indicate that the trajectory of spinning soccer ball is regular and stable. The result is expected to help striker to accurately aim a curly shot or pass at the outside of the ball course and help goalkeeper to easily adjust and quickly react to the ball course.
I will explain about development of this application. Computational fluid dynamics has been conventionally used to visualize and analyze the flow around blood bodies. That means the vortex structure is simulated. For the main CFD methods that this application use is lattice-Boltzmann method for unstable analysis. And then the simulation result obtained from this method is closer to the actual phenomenon than those obtained from statistical analysis. And then this method also facilitates the realization of high resolution visualization and high precision analysis. In addition, there are many studies have been conducted on this application, which are a drag cases occurs under certain conditions during the drag and lift measurements of non-spinning balls, for which wind tunnel tests are relatively easy to set up. Wind tunnel tests also conducted on spinning balls to measure their magnetic force and aerodynamic characteristics.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is HAZIQ bin Abdul Halim, and for the next part I am going to continue with this equation and numerical method. Basically, the application was being related to the lattice-Boltzmann method, which is some sort of method that being used for the CFD, and this Boltzmann method equation formulates the distribution function of f, which consists of x, which is the position, and the speed for the v, and the time for the t, right? And the equation can be written as the equation has been written in the white box in here. And for the description, we will tell by this: the total derivative on the left hand side represents the convective motion of particles, and the right hand side will expresses the complex intermolecular interactions, right? Excuse me. For the next part, which is in this study also, aerodynamics and simulations were performed by using the commercial CFD software, which is the PowerFlow 5.1, the version of it, based on the lattice Boltzmann method itself. And this is some sort of information, the logo and the website itself that we can look into for our further information or general knowledge, right? And I think that's all for me. I'm gonna let my friend to continue this presentation. Assalamualaikum.
For the output, the graph shows the comparison of the drag force coefficient of a non-spinning ball determined from FD analysis and wind tunnel test. The error bars indicate the standard deviation of CD. The graph shows the comparison of A drugs force coefficient and B side force coefficient of a spinning ball determined from FDA analysis and wind tunnel test. Okay, first, the average CS of the spinning ball obtained from FD is slightly larger than the value obtained in the wind tunnel test in this study, but the trends are similar in the average CS increase with an increase in SP. The average CS of the spinning ball increase as RE increase, and considering the average CS depends on the ball speed. This conclusion may be deemed to be within the permissible range. This one does the safety result for the non-spinning and spinning ball in the study are in broad agreement with the result of one tunnel test and can be considered relevant. That's all from us. Thank you.